Just have to change it from public after. Okay, so it's done. We're on YouTube. Okay, so I know I get some feedback here, so I'm gonna take it off and send the sound to a different. One sec, Ariane.
Sure.
Right. Speakers to the headset. Okay, Ariane. So here we go. Where were we? Where were we? We were in Zoom. Return to meeting. I don't want to be here. All right. Ariane, so what are you seeing right now?
Just seeing the screen with what we just did.
Right. It's moving up and down.
Yeah.
All right. Okay. Beautiful. All right. So let's see. Next question was number 30.
Yeah.
All right. So number 30 in the same paper. So you can find that guy. 27, 28, 29, 30. Oh, okay. Trigonometry. So we have this one. Okay, so this is number 30 here. That's it?
Yes, it is.
Right. So we have 0 degrees for angles between 0 and 360 degrees. The equation 3 sine squared x is equal to 8 cos x has only one real solution, given by, well, okay, the first thing we'll start off by doing is saying sine squared x. Let's see, so we're going to solve that. So we have f3 sine squared x is equal to 8 cos x. The first thing we do is the fact that we recall that sine squared x plus cos squared x is equal to 1. And therefore, sine squared x is equal to 1 minus cos squared x. You make this substitution, so the equation becomes 3 sine squared x. It becomes 3 into 1 minus cos squared x is equal to 8 times cos x. You expand out the right-hand side, left-hand side, so you get basically minus 3 cos squared x plus 3 is equal to 8 cos x. And of course, you can carry everything on the left-hand side to the right-hand side, so you'll get 3 cos squared x plus 8 cos x minus 3 will be equal to 0. If you notice, this is actually a quadratic in cos x, right?
Yeah.
So we can try and factorize it, I assume. So b squared, let me see if it can be factorized. If it could be factorized, then b squared minus 4ac should be equal to a perfect square. So 8 squared, let's do not check, 8 squared minus 4 by 3 by minus 3. If that's a perfect square, then I can factorize it. That's 4 3s are 12, 4 9s are 36. So it's actually 64 minus, okay, this is 100. This is 100, which is 10 squared. So it could be factorized. So I take a and c and multiply them. I get 9 and I get the factors of 9. What are the factors of 9, boy? 3 and 3 and 1 and 9. So I have to get 8, so I'll use 9 and minus 1. Okay, so that's actually 3 cos squared x plus 9 cos x minus 1 cos x. That's how I'm going to get the 8 cos x. Understood?
Yes.
Minus 3 is equal to 0. And I can pair these two, and I can pair these two, and factorize. Okay? So I can take out 3 cos x from the first two. What will remain will be cos x plus 3. And here I'll have minus 1. Could be taken out from these two. And I get minus 1 into cos x again plus 3. So what I do have, I have 3 cos x of x plus 3 minus 1 of cos x plus 3. If you have 3 cos x of something and a minus 1 of it, then that's the same as 3 cos x take away 1 of cos x plus 3. You agree that?
Yes.
Can you factorize it? Right. So you have some possibilities. Of means multiply, so I can remove that from there. And for this to get product of 0, either this must be 0 or this must be 0. For this to be 0, cos x has to be equal to minus 3. But we know cosine is limited. Cosine of any angle can only be as high as plus 1 and as low as minus 1. Cosine is confined in that range. So cos x can never be minus 3. Right? That's out of the question. So it's 3 cos x had to be equal to 1. So looking at this side, we could see that 3 cos x is equal to 1, and therefore cos of x divided by 3 is 1 on 3. Make sense?
Yes.
That's the answer. Answer there?
Yeah. B.
Easy to understand?
Very.
Next one.
Okay. Oh, number 32.
Number 32.
Yeah.
Okay. So this is number 32. Seen it?
Yeah.
All right, so tan 2x plus pi n 4 is equal to, okay, so using the formula basically, tan of A plus tan of B. Right, the kind of, we call for this one that tan of A plus B is equal to tan A plus tan B all over 1 minus tan of A times tan of B. So make sense?
Yeah.
Let's substitute what you know. So therefore, tan of 2x plus pi n 4. Now pi n 4 is 45 degrees, right?
Yeah.
Pi is 180 degrees. So pi n 4 will be 180 over 4, 45 degrees. And you ought to know that the tan of pi n 4, whenever you encounter it, tan of 45 degrees is always 1. So you have to remember that. What? Okay. Again, some bad behavior here from this. All right, so this would actually be equal to, I'm going to change that. Not changing. That's not, I'm going to open Word and make a change. I don't know why this software does that. It's a bug they have not yet fixed. Word. Yeah. Yeah. Okay, it should be fixed now. Okay. All right, so let's see. All right, so I was telling you that you should recall that the tan of 45 degrees, which is the same as tan of pi on 4, is always equal to 1. Okay?
Yes.
So that'll be out in mind. So therefore, when you're working this part, tan of 2x plus pi on 4, that'll be tan of 2x plus tan of pi on 4, which will be 1, all over 1 minus tan of 2x times 1 times 1. That makes sense?
Yes.
Yeah, so that basically will just be 1 plus tan 2x, so tan 2x plus 1. Okay, it looks like it will be C. All right, tan 2x plus 1. Tan 2x times 1 is tan 2x, all over 1 minus tan 2x. There you go. That's the answer.
Okay.
Answer there is C. Next one.
Okay, I just wanted to check over number 39.
Okay, yes. Number 39. Number 39, let's see. Okay, so number 39. Okay, tell me. All right, you have to differentiate now, right? So the gradient function. So it's a function of a function here. So I have y is equal to sine of 2x squared plus 1. I'm required to find the gradient function, which is dy dx. Okay, so my solution will involve me making an assumption. I'll let the argument of the sine function let u be equal to 2x squared plus 1. So therefore, we have y is equal to sine of u. That makes sense?
Yeah.
All right. But I'm required to find dy dx. So I use the chain rule basically, and I say dy dx is the same as dy du by du dx. So if I let u be equal to 2x squared plus 1, then the u dx will be the differential of this with respect to x, which is, take it to bring it in front, so you get 4x. Differentiate 1, you'll get 0. Okay? So du
Yeah.
dx is 4x. And if y is sine u, let's get the y du. And the y du will be equal to cos u. When you differentiate sine x, you get cos x, right?
Yes.
So you get cos u. And therefore, your dy dx can be formed by just taking dy du multiplied by du dx. So you have dy du here, and you have du dx here. And so that's it. So dy du, dy dx, sorry, will now be equal to cos u multiplied by du dx. I just want to put a dot instead of a multiplication sign not to confuse you. What u was? U was 2x squared plus 1. So therefore that's equal to 4x then times the cosine of 2x squared plus 1. That's it. That's the answer.
Okay.
Easy?
Very.
What else?
Um. So could you go over number 44?
Number 44.
I just want to make sure I have that one correct.
Okay. Now, do you want to integrate the definite integral of f of x dx from where a is less than c less than b, but you're going from That's kind of hard to see, boy. What is that? Okay, so we're going from B to A. Okay, so you find the integral. That's supposed to be B.
Yeah.
That's A, f of x dx. And it's telling us that x is the integral, x is equal to the integral. And telling us that A is less than some number C is less than some number B. Well, all this is saying is that you can integrate, um, just add two integrals. All right, so I'm going to show what I'm talking about, right? So this is really the formula for this now. All right, so I'm use this. All right, this is a function, right? Function at line is y is equal to f of x, right? At this
Yeah.
point here, this is A. At this point here, this is C. At this point, this is B. That's what this is telling me here. That C is bigger than A, but B is bigger than C. So on the x-axis, I put B to the right of C and C to the right of A. Okay?
Okay.
Follow that so far?
Yes.
All right. So what this expression really is the area under the graph. So the one to find the area, the integral x, this here actually is representing the area under the graph from the line x equal A to x equal B. All right? So this is the area I want me to find. Okay, that entire area. Okay? Well, that area
Okay.
will be the sum of two areas. I can make that area, if I draw a line down here like that, if I take this area from here to here, and I find that, and then I take this area from here to here, and I find and I put the two areas together, I will get the area, overall area. That makes sense?
Yeah.
So this first area here, this area here is really the integral of f of x dx from A, from, what was it? Was it from B to A? And A was less than C, which was less than B. Okay, so I'll just make it from B to C. So I'm going from B to C. That's B to C. And I'll give me this area here. I'm sorry. This area here. Give me this part here, going from B to C. And then I add from C to A. And that'll be the overall area. Yeah, that'll be this overall area here. The two individual areas, when you add them together, you'll get the overall area. Get my drift?
Yeah.
Right. So this is the area. This area here corresponds to this part here. And this area here corresponds to this part here. Add those two areas together and you get the overall integral from B to A. That's it. Right? So if you change around the addition is commutative. Right? Did I say bigger or smaller, boy? Let me see if I saw that right. Yeah, B bigger than C and C. All right. Yeah. This is area bound. That represents the area bounded by the curve. Trying to confuse you, but um, C is one in the middle, so you're going from A to C and C to B. So C will be the answer.
Okay.
Right? A to C. Let me see if I can show you that. I go in from, you see that laser moving around?
Yeah.
Right. This area here from A to C X equal to C, that'll give you that area here, bounded by that. And then from C to B, we find the area bounded under the graph from X equal to C to X equal to B. That's that area there. The area will work out to the area basically work out to the same thing. If you invert the limits, if you invert the limits, you will get to let me see what they have here. They have AC. All right, so let's. Ooh, nonsense. A is nonsense. Because A is actually the first part of A. Okay, let's see why it's not. Why the different parts are nonsense. Because I think that's what you need to understand. Okay, this first part here is the area bounded from this line here where 0 up to A. So they're taking this area here, which the question never really asks us for. I want to get a nice color, orange, right? Right, that area there is this area here. I'm going from X equal to 0 to X equal to A. X equals 0 to X equal to A is the X-axis here. And I find any area bound under the line Y equal F of X from X equals 0 to X equal A. That has nothing to do with what we want to find. We want to find the area going from A through C up to B. Look at here, A to B. They start with B and A, but the area is the same, whichever way they come from. You get where I'm coming from? The area of the
Yeah.
graph, if I was going from B to A, let me see if I can put a if I was going from B to A or from A to B, the area of the shape is the same. And what it is the sum of two areas. The area of this piece here, A to C, because told us that C is between A and B, and the area from C to B. So looking for those two intervals. It's in A to C here, and it's in B to C here. Let's know. A to C, B to C, A to C, C to B, A to C. So it's starting with A and ending with C, and then it's starting with C and ending with B. All right, wow, interesting. Okay, so let me see how they try to confuse us, right? If I do this integral as is, you need to go from A to C because A comes before C, and then C to B. What they did here, they put A to C and they put B to C. Now, the problem with this one is that B is bigger than C. So I get a negative number when I work out this. Understand that?
Okay.
I don't understand that.
Yeah, I understand.
Because the limits are reverse.
Yeah.
Right, so this one here, let me zoom in a bit. All right, so they're trying to confuse you there. All right, so let me clear up all of this. All of this, because what I'm talking about. Okay. See that A is less than C, which is less than B? It means on the x-axis, you'll encounter A first when you're going from 0, then you'll meet C, and then you'll meet B. Now, when you're integrating, normally it is the upper one that takes away the lower one. So like if I say integrate x between limits of 1 and 5, the x, you'll integrate x first and you'll get x squared on 2, right? And then you use the limits 5 on top and 1 on the bottom. So that'll be, get a little skinnier. That'll be 5 squared on 2 minus 1 squared on 2. Because of how they have this written, 5, 1. If they wrote it this way, integral 1, 5 of x squared of x, sorry, dx, that would have been, yes, it would have been x squared on 2. You'll have limits 1 up here and 5 here, and that will give you 1 squared on 2 minus 5 squared on 2, which is the negative of this here. Am I making sense?
Yeah.
This is actually 25 on 2 minus 1 on 2. 25 on 2 minus 1 on 2, that's 24 on 2. It's actually 12, and this one would have been minus 12. Okay?
Okay.
Now, so once you change the limit, the axes, change the limits around, you get a different sign. Now, they very carefully put B and then A. So they started with the highest one and went back to the lowest one. So let me just take off all these annotations here, move all of them. Let me make sure you get that, because I can see where the confusion will come from. This is what they wanted us to find. Let me make sure. Zoom out, zoom out. Right. Right, so they want me to find this. Now, this is actually really equal to, normally we don't like, what we like, we don't like the lower number. This number must be a smaller number, not the bigger number. But the question is telling me here that B is actually bigger than A. So this is actually equal to negative, and you can flip the limits now. X equal to B, X equal to A, f of X dx. Think you understand what I just did there?
Yeah.
Yeah, because the limits were B and A here, if X is that, then if I flip the limits, put B on top and A on the bottom, I must change the sign to negative.
Yeah.
Right. So that would actually be now, that would be equal to minus, and I take this integral and break it up into 2 steps. An integral is really a summation. So if I have a curve doing something like this, to integrate is to pull things together, right? Integration means to pull things together. So they want to get this area here up to here, from A up to B. And what we're saying is we can split it into 2. We could just go up to C first, and then take that and add it to what we get from going up to B now. 2 different areas. And this area is found, this first area is found by integrating from x equal A to x equal to C, the integral of f of x dx. And this area here is found by integrating the same function f of x dx. It started from x equal to C, going up to x equal to B. Okay? Dx.
Yeah.
Now, all of that has to be negative. It's supposed to be negative because of this negative sign here. Okay? But what I suspected I wanted to do was to find the area under the graph. And area cannot be negative. Area is actually positive. It's actually the area under the graph. So you could just drop the negative sign, or you can actually write this way. This is equal to the integral, and take the negative now and apply it to each one. And when you do that, the intervals will flip. So the C will come on the bottom, and A will come on top. So I get C, A. I flip the integrals. I move the C from here, the A from here, flip them, f of x dx plus, see, negative times that is what causes the intervals to flip. The negative times these 2 things here if of course the intervals to flip. The negative again, the negative again, times this thing, because remember everything in a bracket, because those intervals to flip as well. So you'll get x equal to b on the bottom, x equal to c. Intervals flip, c to b, b to c. Right. F of x dx. Right, so c to a, going backwards, b to c, going backwards. That's it. Now, if it is area, it doesn't matter. The area is the same whether I put C or A, if interchange C or A is the same. So we're looking for this answer in particular. If you go get this answer, we could flip it. So let's look for that answer there. I've seen C on top. Okay, so this is wrong. This one is obviously wrong. What this one is actually doing, this one is actually adding. Let me show you what the first one is. The first one, if that's what your graph looks like, and that's A. This first one, this is A, and then this is C, and this is B. The first answer is actually adding the integral from 0 to A. So the first one is that is the first area here, that is 0 to A. That this is this area here. Understood?
Yeah.
And this one, going from 0 to B, is now this. So I including even this part, the second part. That makes no sense, right? Adding. So adding the orange area to this blue area here, madness. Totally wrong.
Yeah, that makes no sense.
Right. The second one is we're going from A to C. A to C, and then they're going from C to B. That makes sense. Look, I have it here, A to C and C to B. We need to have a negative sign on the outside. Okay? That's what
Yeah.
you're doing. Right. This one looking all right. So looking all right. So no, I'm sorry. This one looking all right. So let me change the color of that. All right. This one looking all right. The sign is what is troubling me. The sign needs to be negative. Right?
Okay.
Okay. So let's look at C. I'm going from A to C. I'm going from A to C, so I'm actually so, let's see. Right. Right. So that one. Oh Lord. Oh Lord. A, B, A, C, B. All right. This the third one. I'm going from A to C. So I'm going from here to here. So that'll be we got different color. That's this area here. So I got that area, A to C, and it looks good because I went from the lower to the upper so far, so that's good. But then I'm going from B to C. And to go from B to C, I'm going backwards now. From B to C. No, I wouldn't work. And with this one here, my goodness. I'm going from A to C, 0 to C. Wow. Let me see that one. Wow. Paste again. I'm going from A to C. So this was 0, this was A, this was C, this was B. So I'm going from 0 to where? 0 to, last one is 0 to A. So I'm going up to here. I'm taking this area here. taking that area, bounded by that, adding it to which area now? Add it to C, 0 to C. So adding that now to this nonsense. I'm adding that to this area here as 0 to C. So so this part will be added twice because adding it from 0 to A, then 0 to C will be this again and that. And what I want to take away from that, take away 0 to B. I want to take away an even bigger area than that from it. Nonsense. So I want to take away different color, different color, different color. Let me see a different color. All right. So I want to take away this area from all of that. I think everybody knew that is madness. So I will take B because B, even though it's negative to that, whenever we find an area, we ignore the sign. So the aim was right to find the area of the graph from the beginning. That's the whole area. The whole aim of the question, and therefore B is the answer. What answer you had? What answer they give you in the question?
C.
That C as the answer?
Yeah.
Mm-mm.
So it's B.
A to C and B to C. Mm-mm. Mm-mm. The answer is B. C is in the middle.
Yeah, okay.
Okay, they're going from A to C and then C to B. Oh, the answer is C.
Yeah.
Yes. That would work. That would work. I'm sorry.
That's okay.
Watch it here. X is A to C and C
To
to
B.
B. That's what I have there. A to C and C to B. I'm sorry. This is A to
Yeah.
C and then there's B to C coming backwards, right? So this one, A to C and C from lower one to B, right? That's correct. The answer is C.
Okay.
You understand?
Yes, I do.
It's starting with one, going up to that one, and when that one ends, it starts with where he ends and continues. Or you go in the opposite direction. It starts from B to C, and when he ends, you go from C to A. Right? There must be a continuous flow.
Yeah, okay. I understand.
Right. So the answer is A to C and then C to B. Right, that's correct. So this is not correct. This one is correct. So that here A to C, A to C, and C to B. And if you flip it around, negative, that would have been C to A. This would have been C to A. This is negative, this would have become C. The other one would have become C, that would have become A. And flip this one around. This one was flipped around properly. Yes, this is B and C. That's correct. B and C. So in other words, you're going from B to C, going backwards, going from B to C, going backwards, and then from here, going from C to A, going backwards. Right, that's correct. Answer C. Understood?
Yeah,
I hope so. I really do. Next one.
I do. I understand. Okay. I think that's it for the 2019.
All
But
right.
I do have another question that I want to clarify in 2017.
2017. 2017. Okay, let me see if I can get that one. All right, which question in 2017?
Number 30.
30?
Yeah, 30.
Okay.
I just want to clarify that because I worked this out and I got an answer, but I just want to make sure that that one is correct because it's trigonometry.
Okay. Okay, let's see. Larger. Okay, so number 30. Okay. Okay, so this is it.
Yes.
All right, so let's see. So the smallest positive angle in radians within the range 0, less than theta, less than 2 pi, that satisfies the equation 2 cos theta minus 1, cos theta minus 2 is equal to 0 is, well, this is a kind of baby. Let's see why. In the first instance, you were solving an equation and reach down to this. 2 cos theta minus 1 times cos theta minus 2, that must be equal to 0. So they already factorized it for you. So either cos theta is equal to 2 is the answer, or the number, the statement leading to the answer, or 2 cos theta is equal to 1. All right? That makes sense?
Okay. Yes.
Yeah. So either one of those. Now, we know that cos theta is trapped between minus 1 and plus 1. You can't get numbers like 2 and so on. All right? So cos theta being equal to 2, that's invalid. That's invalid. All right? This will give you no real answer. That's invalid. So you know that cos theta now, 2 cos theta is equal to 1 had to be the answer, and therefore cos theta had to be equal to a half, right? Make sense?
Yeah.
Right. So again, all you need to do is remember the shape of the different curves. So let's see. All right, so I'll try here. Different curves. So boom. And then on the next line. All right. So I want to draw the cosine curve now. All right, and the cosine curve actually starts off at 1. So, and let's say this is 90, 1, 2, 3, 180, 270, 360. Cosine curve starts like that. At 90 is 0. It'll be here at that point. And here at this point. And then back up to here at that point. Okay, that's a whole cycle there.
Yeah.
They tell you that cos theta is a half. So this is the graph of cos theta versus the angle theta. So this is a half will be somewhere here. Cos theta half at 2 points between 0 and 360. There, as well as so. Oh Lord, move from blocking my view. All right, so let's see. Oh, we're blocking my view even more now. All right, now I get it. All right, so from here, I draw a line straight across. All right, so wow. Okay, so this is a half here, right?
Yeah.
This is 0.5 here. There's 1 here, 1.0. This is 0.5. 0. Well, the smallest angle, this angle here will give me, that angle they will give me my answer. The next answer will be here. As the next time cos theta is a half, happens at this angle. So this theta 1 and that's theta 2. Okay? Now you're
Okay.
supposed to know by heart that the sine, cosine, and tan are different angles. Well, cosine at 60 degrees is a half. Right? So this angle really is supposed to be 60 degrees if you're using the degree system, but it's in radians. So 60 degrees is actually pi on 3. Right? This will actually be pi on 3 radians. 180 on 3, right?
Yeah.
And using symmetry, if from here to here is 60, then from here coming back here must be the same distance, 60. So this is 360, so that be 300. This would be 300 degrees here. You understand that?
Yes.
Because here is 360. And the symmetry, this distance backward had to be 60 backward. The land on this one is 60 forward. Make sense?
Yes.
Right. When they fall on each other across this line, they land on each other. Right. So this is 300, which is it's actually like 5 times 60. So it'll actually be 5 pi on 3. 5 times 60 pi on 3 radians, or 5 pi on 3 radians. Now the one is small of the two numbers.
Yeah, because they said the smaller positive
Right, the
angle.
smallest positive angle. So you're looking at pi on 3.
Okay, good. Thank you, sir.
What else?
Hmm. I just looking through all my papers to make sure I'm not leaving out any questions.
You are seeing a chat at the side of the okay, you're not on YouTube. I'm not put it up on YouTube and see. Because what happens, I have some people trolling me.
No problem.
I was looking on YouTube in the time being. I have some very wicked students in my school who continuously troll me. Very wicked guys. What's happening here? Why isn't the computer coming on? Okay. All right, let's see. Okay.
Okay, so I found one.
All right, so I'm seeing a live stream now. Okay, so somebody okay, so this person today didn't put anything nasty. That's thank the Lord. Okay. And that's the funny thing, the students are polite. I don't mind letting them come to the class, but some of these guys really aren't nice. All right, so you found the question?
Yeah, I found another one. This one is in 2013.
2013. Okay, so let's see if we could find that 2013 question. Okay, I hope I have a good file here. Review. What's the question number?
25.
25. Okay. Okay, 25. Yes, no. Okay, I think I found it. Tell me if this is the question here.
Yes, that's the question.
Okay, so again, this time we tell the angles between pi and 2 pi. And telling us that 2 cos theta is equal to root 3, and I want to figure out what pi is. Okay, so again, it's cosine, the cosine graph again. So let me take a borrow that graph from up here. All right, so I borrow this graph. Okay, and place it back there because it's really easy. Now let's just move all the other annotations we had on them. All right, so let's move this line, all of this. That's a line of symmetry. So we want to find the angle that satisfies that equation. Okay, so just clear the diagram up a bit, right?
No problem.
All right. Okay, so that's the cosine graph. All right, and we are seeing that they want to find the angle, but the angle must not be between 0 and 2 pi. The range they're concerned with is between pi and 2 pi. This angle here is pi radians here. On the axis, that's pi radians. And this here is 2 pi. So they're looking for angles that satisfy in this region here. Must be in this region here. In that little window. You with me?
Yeah.
Between pi and 2 pi. So that being the case, let's see what I really want to get. So, well, if 2 cos theta is root 3, then we ought to know that cos theta then will be root 3 on 2. Now that happens, you're supposed to know all the different, for trigonometric ratios for 0, 30, 45, 60, and 95. Well, the cosine of 30 degrees is root 3 on 2. Okay? So that means we're
Okay.
referring to this angle here. So let's say that's 90, 30 should be around here. Right? So you go up here, root 3 and 2 is about 0.866 when you come across here, right? This will be 30 degrees here. That's one of the angles. But at which the cosine is 0.866, right? Cosine of the angle theta is 0.866. That's what they're saying. I'm going to find the angle theta. The other angle will come across here in the third quadrant, fourth quadrant. It'll be this angle here. And again, because of symmetry, whatever distance I travel and going from 0, let's now zoom in. Right, so you can see what I'm talking about. Right, whatever distance I travel and going from 0 to 30, because the symmetry about the halfway line is the same distance I travel from 2 pi going backwards to here. So this is 30 degrees. So then here, going backward here must be 30 degrees as well. The jump from here to there, that jump must be 30 degrees. So this was 360 degrees, right? Or 2 pi radians. We jump in. This is actually pi on 6 radians here. 30 degrees is pi on 6, right? You agree with me?
Yes.
30 degrees is pi on 6, all right. So we jump from, let me zoom in a bit to make it a little more obvious. Right. What I'm saying is the jump from here to there is pi on 6 radians. That jump there. See that?
Yeah.
All right. I'm saying that that's also the jump because it's a symmetry from this point here to that point. That must also be pi on 6. So this is 2 pi here. This angle here will be 2 pi, take away pi on 6. Right? That makes sense?
Yeah.
2 pi is actually 12 pi on 6. 12 on 6 is 2, right? 2 pi minus pi on 6. And this is 12 minus 1, that's 11 pi on 6. Make sense?
So you can explain that last part over one more time?
Okay. All right. So I'm saying that this angle here is 30 degrees, right?
Yeah.
Do you agree 30 degrees is pi on 6 radians?
Yes.
Right, it's pi and 6 radians. Now, what I'm saying is the graph is symmetrical about this line here. That line here cuts the graph exactly in half. That line cuts the graph exactly in half. Right. So first of all, I want to get the angle for which. Okay, let's look at the question told us. Where's that question? All right, it told us that the cosine of the angle must be 0.866, root 3 and 2. This value here is 0.32 root 3 and 2 here. So when I come across to read the graph to find out what angles have that cosine, there'll be two angles between 0 and 360 that have that cosine. This first value here, and I continue across on the line, another value here. That makes sense?
Yeah.
Those two angles have the same cosine, 0.866. Make sense?
Yeah.
Right. You see this distance? The graph, it's actually symmetrical. If you draw this line here, you cut the two sides of the graph into identical twins, into actually identical. You could fold the graph across that black line, make a crease along that black line, and every point, like this point here, will fall perfectly on that point here.
Okay.
And this point here will fall perfectly on that point here, if you fold it about this crease. That makes sense?
Yes.
And this distance here, if from here to there, will be the same as this distance, and you see, from there to there. It's supposed to be the same. Understood?
Yeah.
The left-hand side and the right-hand side are like identical twins, just like a mirror reflection of the other. So, if I want to know what angle this will have fall on, I know this will have fall on this. I knew this will fall on this point, because draw a line straight across from me, I'm not for sure. I know that this point will fall on that point. I know that this point here will fall on that point when I fold it. I know that this point will fall on that point when I fold it about the black line. You understand that?
Yeah.
Right. So the distance from here to here, whatever that distance is, let me use my point. Let me see. Let me use a red. Right. So this distance from here to here, watch. Up by the arrow, it's in up here. Right. This distance from here to here, whatever it is to get to that point, had to be the same as the distance from here to here. It's the same distance. So I said to you that if from here to here is pi and 6 radians, this is 0. 0 here. This is pi and 6 radians here. Then the distance between here and this point here had to also be pi and 6 radians. That distance there. You understand that?
Yeah.
Sure?
Yes.
Right. The distance actually is pi and 6 radians. We're not far fact, it's 30 degrees. So the distance in angle is pi and 6 radians. So then, if this angle is 2 pi, I'm going to get the other, I have to go back by pi and 6 radians to get the angle that matches with this angle here. That angle and that angle, both of them have the same cosine.
Okay.
So I'm going from 2 pi, which is this position here, I'm jumping backwards by pi and 6 radians to get to the point there. And that angle have the same cosine as the angle that is pi and 6 radians from 0, move pi and 6 radians to this point, both of them have the same cosine. Understood it?
Yeah.
Sure?
Yes.
All right, so if this is 2 pi here, as 2 pi here, let me move all of this. All right? Put a nice red line here now. If this is 2 pi here, the angle to the left of it will be pi and 6 radians less. So I'm going backwards to the left, so I have to subtract pi and 6 radians in a jump. to come to the angle. In the third quadrant, remember, I'm interested in angles only in this region here, only in this pink box from pi to 2 pi.
Yeah.
Right, so if I take 2 pi and I subtract pi and 6 from that, I will get the angle whose cosine is the same as that angle there.
Okay. Okay.
You don't remember we did all of this?
Hold
Right.
on.
You don't remember when you did all of this?
Yeah, I do.
The graphs are symmetrical, so you're looking for opportunities to see where symmetry will help you not have to learn a whole set of formulas.
Yeah. No, I
Right?
remember all of it. I remember it.
Right, and you were getting it out really well. Right? So what I'm saying is that this angle here, when you go to your calculator and you find the cosine inverse of 0.866, it will tell you the angle is 30 degrees, which is the same as pi on 6 radians.
Okay.
In the first quadrant. But the calculator doesn't readily give you angles in the other quadrant. So you want to find the other angle where the cosine is 0.866. So you have to draw this line. Let me see. That from there. That so you can see clearly, right? Right. So I'm saying this point here is 0.866. Look on the arm. The cosine is 0.866. Two angles have that. This angle here. This angle here. And if you continue the same line across, the next angle between 0 and 360, that angle there. Those two angles have the same cosine, 0.866. You with me?
Yeah.
Right. But the graph of cosine is always symmetrical. They have different points of symmetry. So I'm saying, for instance, if I draw a horizontal line across the graph like this. See that green line I just drew?
Yeah.
I just drew a green line coming across the screen here.
Yeah, I see it.
That line will be a reflection of this line here. And next green line I just drew in. This green line is a reflection, will fall exactly on that green line. This length and that length supposed to be exactly the same. Length of this green line from here to there, and that green line from there to there. You see what I'm showing you?
Yeah.
They are analogs. They are reflections of each other. This line, let me change the color of this line, highlight it. Right, let me try this one here. Right. Right, so this distance from here to here, look at drawing a blue line across here to hit the graph. From here to here, that distance will match perfectly with this distance from here to there. Those two will be exactly the same length. Are you following that?
Yeah, I am.
Right. So I could tell when somebody has not picked up perfectly as yet. So let me see if I can move that line there. All right, trying to move some spots here. Oh Lord, that's when I don't want to move. Okay. So Ariane, there are distances that are equal because of symmetry of the graph. Symmetry. So if I put a point here, A, and a point B here, the length of AB will be the same as if I continue the line straight across, and I call that point here C, and that point D, AB and CD will be the same length. I just drew my graph bad, but AB and CD are supposed to be the exact same length.
Okay.
If I draw a line from, and incidentally also, this is distance from B to this point here. This line I just drew in here, see I just drew in a line there? I just drew in a line, right? That line I just drew in, that line had the same length up to the thing from there to there. They must be the same length. So I call this point O, B to O are the same distance as O to C. That distance and that have to be the same. You understand that?
Yes, I
For
do.
one to fold perfectly over the other, all the distances have to be the same. One is a perfect. When you did reflection in physics, they tell you that the distance of an object behind the mirror, an image behind the mirror is equal to the distance of the object in front of the mirror.
Yes.
If you stand up 3 meters in front of a mirror, the reflection seems to be 3 meters behind the mirror. If you walk towards the mirror by 1 meter, 2 meters away from the mirror, the reflection will walk 2 meters, a meter too, towards the mirror as well, and it'll appear to be 2 meters away behind the mirror. Not so?
Yes.
Right. So that black line in the middle is like a mirror line. That line there. This line is like a mirror line. All distances from one point that have a matching distance on the other side. All right, so let me just, all right, so let me take the whole thing off again. All right, I see you having difficulty with this.
No, sir, I understand this, I remember when we were doing it. I don't have a problem with it.
All right, so I'm gonna paste again and see what we have here now. All right, so let's clear up this guy now. So this is what we came to. I think it was 30 degrees we said, right? So this is what the cosine graph looks like. Right, of course my shape isn't perfect. Undo. All right, so you said the cosine of the graph, cosine of the angle. We said 2 by cosine the angle was root 3, which means cosine of the angle is root 3 and 2. And you're supposed to know that the angle between 0 and 90 degrees, that has that cosine, is 30 degrees. So
Yes.
theta will be 30 degrees in the first quadrant. But the question never asks us for questions in angles in the first quadrant. They ask us from pi radians to 2 pi radians. That's what they're looking for the answer. So they want the answer in this range here. You with me?
Yes.
Right. We know that if so we come here with 0.866, we draw a line across here maybe. I'm drawing this line here, that's why I find the inverse cosine. When you come down here, again the inverse cosine. I know the angle is supposed to be 30 degrees. You're supposed to know that this will be 30 degrees. Or 180 on 6 or pi on 6 radians. Understood?
Yes.
That means that's the distance from this line from here. Let me get the arrow. That's this distance here. I just put an arrow there. You see that arrow there?
Yes, I see it.
That's the distance there. Right. So what they're saying then, if I was to fold this graph over, okay, about the halfway line, this line here, undo that, right. Right. If I was to fold that about this line here, as this line of symmetry, right? This line here is a line of symmetry. This point here will fall exactly on that point there. If I fold the graph, make a crease here. If I make a crease along this line, and then fold so that this line falls on that line, then this dot will fall on that dot here.
Yes.
Right?
Yes.
Right. And this distance here, if this is 0 here, if this is 0 here, 0, and this is pi and 6 radians, the distance between here and here is 30 degrees or pi and 6 radians. The length of this arrow here is actually pi and 6 radians.
Yes.
right?
Yes.
Right, so then if I draw this line down from here, the distance from here to here will be the same pi and 6 radians. This distance, I mean, because I didn't draw a diagram properly, not looking like the same, but let's say that, let's say that, right? I am saying that this distance here will that be pi and 6 radians, this distance here. You with me?
Yes.
Because this distance and that distance will match up perfectly. This distance here on this side and this distance on that side will match perfectly because you draw a line from here straight across to hit here. You understand?
Yes, I understand.
This is like the object, this is like an image, and this is like a mirror line here. The distance from here to here is the distance from here to here. The distance from here to there is the distance from here to there. Which means, therefore, the distance from here to here is like the distance from here to there. These distances are the same. Let me see, when they get a nice blue, sky blue. Right, I'm saying that this distance from here to here is saying the distance from here to here. This distance here is that same distance there. That distance we know to be pi and 6 radians. This angle here we know to be, this angle here we know to be 2 pi radians. That's a complete, that's 2 pi radians. Distance from this line to that line is pi and 6 radians. If this is 2 pi, if this is 2 pi here, and this distance here is pi and 6, the distance itself is pi and 6 radians, then this angle here will have to be 2 pi, take away pi and 6 radians. Understand?
Yes.
Sure?
Yes, I am sure.
All right. But 2 pi is the same as 12 on 6 pi. So I have a common denominator to subtract. 12 on 6 pi minus pi and 6. 12 minus 1 is 11 pi. So you get 11 pi and 6 radians. And that'll be your answer.
Okay.
Make sense?
Yes, it does.
Answer A. Really simple. Make sense?
Yes, it does. I understand.
Okay. So Ariane will have to run because our next class starting.
Okay, no problem.
But any other questions? Well, tomorrow we have class again, right?
Yeah, we do. At 9, right?
At wasn't it 8?
No, we said 9.
9. Okay, all right. So so you understand this?
Yes, I understand.
All right then. Okay then, so you have a good day.
You too. Bye.
All right, bye.